These jets are naturally produced out of ice on the surface of a rock. And the second possibility is that they might be thrusters on the technological spacecraft.
Is it streaming out? What is all this? Is it breaking up after possibly going behind our sun? A little confusing because this all comes after last week images showed the object with no tail. Weird. Is it streaming out? What is all this? Is it breaking up after possibly going behind our sun? A little confusing because this all comes after last week images showed the object with no tail. Weird.
You've seen tough bites out on the water, but what if the ocean changed the rules mid-cast? Today, scientists just logged a 10th anomaly in 3I Atlas, an interstellar object that keeps breaking comet playbooks. I'll show you why a brightness stretch at a 106-degree angle near the sun's direction and jets that vanish in an R-band filter have researchers saying the standard model won't hold. Stick with me to learn the checklist I use when nature stops behaving, so you can spot rule-breaking signs on the sea and in the sky. Before we move on, I'd like to ask you a small favor. If you appreciate this content, please take a second to like this video and subscribe to the channel. Over 98% of you watch the videos without subscribing. It costs you nothing, but it makes a huge difference to us. So, did you click the subscribe button? Great. Thank you so much. Now back to the video. You set the hook and the line runs straight into the current. That's 3I Atlas, pushing sunward when every lesson says the tail should stream away. Let's dive in. The new Nordic optical telescope frame shows a stretched glow at about 106 degrees on the sky, while the sun lines up near 115 degrees.
So how did the object go from an anti-tail to a tail to a no tail to an anti-tail to whatever it is that we are now seeing?
These jets are naturally produced out of ice on the surface of a rock. And the second possibility is that they might be thrusters on the technological spacecraft. Even after it passed through perihelion, it was heated by 770 watts per square meter. And we know that the previous plume of gas was mostly carbon dioxide.
The object sits about 1.43 astronomical units from the Sun and 2.16 astronomical units from Earth. The crop spans roughly 500,000 kilometers across, like scanning a whole bay from a drone. You can see the light favored one side. It leans toward the sun, not away. Here's where it gets strange. Wide field shots caught long jets, but switch to the R-band. Filters that quiet most gas emission, and those long jets fade. It's like hearing a splash, but your sonar shows blank water. When gas lines get muted and the structure thins out, you're not reading classic gassy plumes. You're looking at dust or sunlight bouncing off grains. With a normal comet, dust trails downwind. The solar breeze pushes like a steady tide, and the dust tail runs leeward. Anti-tails show up when geometry stacks the deck along the orbit line. But this feature points sunward. That's a salmon sprinting upstream in dead still water. No tide to blame, no crosswind to hide behind, just the flow going the wrong way. Now take the jet outflow read at this distance. The expected outflow lands near 0.4 of a kilometer per second, about the sound speed in that gas. Keep that pace moving for 1 to 3 months and carry the mass 1,000,000 kilometers out.
Well, thanks for having me. We see more than 7 jets that are tightly collimated coming out of this object. And of course, there are 2 possibilities that we considered all along, that in carbon dioxide ices can sublimate at a much lower temperature than water ice. So we should have seen it break up, or at the very least disintegrate to a very dense and massive cloud of gas and dust that is pushed away from the sun. So what I'm saying is, you know, that there are things we don't fully understand about this object. That's what makes it exciting, and I think all of us will wait for the data that will come in the coming weeks.
And you get a density count in the millions of protons per cubic centimeter out there. Multiply by the outflow speed, and the flux turns huge, like a fire hose measured in billions of tons per month per million square kilometers. That's the claim on the table, and if you accept those numbers, the source has to feed a lot of mass for a long time. Translate that load to deck terms. To drive that outflow with sun power, you'd want a hot, broad hull, tens of kilometers across. But the body's size limit from Hubble sits around 5 to 6 kilometers. That's a skiff pulling a freighter's wake. If the wake is real and that big, the engine doesn't match the spray. Something in the math, the fuel, or the shape has to give. Go back to the R band. Those filters cut out most of the usual gas lines. If the jets vanish under that filter, then the structure we're chasing is either dust-heavy or reflectance-built. That means the brightness could come from sunlight bouncing off a grain flow, not from gas glowing on its own. It also means the simple gas drive model won't explain that sunward stretch on its own.
Is it streaming out? What is all this? Is it breaking up after possibly going behind our sun? A little confusing because this all comes after last week images showed the object with no tail. Weird.
Before they have a chance to turn around and show up as a plume of glow behind it, away from the sun. That's one possible interpretation, but otherwise I just don't know what to make of it.
You'd check grain sizes, charge effects, and how light pressure sorts fine dust. You'd also check for a thin, forward scattering sheet. Dust can glow brighter when you look near the sun's line. Stack the earlier odd fronts, quick. The path runs retrograde yet hugs the ecliptic tight. A solar-directed jet showed up in late summer. Size and speed point in the wrong order. Composition hints lean metallic, not a dusty snowball. Water sits scarce. Polarization runs strongly negative. The approach lines near the old WOW signal direction, near perihelion, the light surged blue. And now we see solar-directed behavior in this new frame. 9 fronts, 1 squall line. Each one by itself is a squall. Together they look like a weather shift. So here's the payoff in this stretch. The 10th anomaly ties the set. Directional brightness points sunward, while the spectrum goes quiet in a band that hides gas. When tails run against the tide and your sonar goes silent, you stop treating it like a standard bite. The usual lure won't tell you what's going on. You need a new read, a new plan, and a slower hand on the reel. Next, I'll hand you a simple checklist: how to work unknown water, and how to read a sky oddity when the rules stop working. We'll break it down so you can test a claim, scan the field, and call a clean shot before you swing again. When the signal runs against the current and your tools go quiet, stop guessing and switch to a method. Observe cleanly. Compare against known cases. Stress test with simple checks. Then decide on what holds up. Use that checklist on your next weird bite and on the next 3 iAtlas update. Share your read in the comments and subscribe for more trips and tests. Watch how your calls get sharper when you work the steps. The ocean and the sky both reward patient skeptics. Watch for the rule break, then work the pattern. That's how you stay steady when the water pushes back and the gear stays silent.